Hello and welcome to this edition of Movement and Rhythms of the Heavens. I'm Mark Breen, the Planetarium Director at the Fairbanks Museum. And what we're going to discuss to start out is just how those motions take place. And we'll start with something simple, maybe something you haven't really paid attention to. And yet it's quite easy not only to pay attention to it, but you can also observe it yourself. So that'll be one of the key things that we're going to work on. So let's start with the daytime sky. It doesn't seem like the hotbed of astronomy, so to say, but that really is one of the keys to understanding the motions that you see. So we're going to start with a view that has a look at just a daytime sky. So you can see here, there's the sun working its way across the sky, although it doesn't seem to be moving right now. That's because the motion is very slow during the course of the day. You can see the sun. This is its position and just slightly after 10 o'clock in the morning in April. Now, if we go forward in time, and you can do this yourself, this is a program called Stellarium. There are directions on downloading it at the museum's website, and it's a free download, very easy to use, and there are lots of instructions right in the program itself. So we're going to go forward in time. We're going to increase the time. If you look at the very bottom of the screen, you'll actually see the time speed up here. And so we're going forward just a little bit faster. Let's actually just engage that. There we go. And you can start to now notice the sun moving across the sky. But of course, time is speeding up considerably. Now, the motion of the sun across the sky, generally we know it goes from east to west. And if you look, you can see direction letters. There's S for south, and there's southwest. So if we change our view a little bit and head over toward the west, you can see the west coming into view. But we're going to slow that motion down because we want to take a little closer look at this particular motion. So we're going to, first of all, get a little bit closer to the horizon so you can see things just a little bit better. And now you can see there's west. And so we think about the sun rising in the east and setting in the west. So one of the first things that you might notice is the sun is not directly above west. So let's watch this motion. We set the sun in motion now, again, speeding up time. You can see the sun is angling, not straight down, but angling toward the west. In fact, if we stop it right there, you can see now the sun is directly above west, but it moved kind of on a diagonal. Any idea why that is? Well, you can kind of take some thought about that. But in the meantime, while we're thinking about why the sun might have moved on an angle, let's let it complete its motion. It's toward the end of the day. The sun will be setting below the horizon fairly soon, so let's let it do that now. We'll get it to the horizon. There it is. Now, of course, the horizon here has a hill. That's pretty common around here. Hills, trees, buildings, these will all affect exactly where the sun is setting along the horizon. And this is kind of your first little project that you can do with this edition of the Movement and Rhythms of the Sky, is you can measure for yourself where the sun sets over an extended period of time. So I would suggest looking for a western view. Maybe you're outside your house, maybe even inside your house, where you have a relatively good view to the west. Now, it might indeed have hills and trees or buildings. That's quite all right. That's acceptable. What you really want to do is observe what the sun is doing. And so that's one of the key things in any science, observing, watching what the sun does. So we're watching the sun, it's setting here, and you could actually sketch out maybe this horizon. In fact, if we just zoom out just a little bit so we can see just a slightly wider picture extending from northwest on the right-hand side to southwest on the left-hand side, there's the sun, and we can actually kind of sketch out a basic picture of the horizon, and we can do two things. We can write down where the sun is setting, or we can actually draw it, but we can also mark the time. Now, the time on here is indicated in 24-hour time. So in other words, 1904 is really 7:04 p.m. So you can write what time you see the sunset, and where it sets, or draw where it sets along the horizon. Now, this motion, going from east to west, is one of the simple basic motions of the sky, and yet, like I said, it may not be something that you have observed very carefully. So one of the advantages of this particular program is that you can see changes not just on a current basis, you can actually watch the sky over any particular period of time. Now, before we give any answers away, and this is something you'll still want to chart out, if we change the time, here it is in mid-April, where would the sun set, would you say, in mid-May or mid-June? One of the things you probably know about the sun, you know that the days are longer during the summer, so you would expect the sun to be higher in the sky. But where does that affect where it sets on the horizon? Does it set in the same place and just move higher across the sky? What is going on? So this is one of those predictive parts of science. It's something that is part of the scientific process, but we know it as sometimes as the scientific method. And you base it on observations that you've taken. So in this case, we've watched the sun, we've seen it set. We don't have a lot of observations just yet. And that is what I'm inviting you to do. Take some observations, make some measurements of where you can see the sun in the sky, and specifically where it is setting along the horizon. So here it is, it's a little bit after 7 o'clock, the sun is setting in mid-April. So the challenge is, where do you think the sun is going to set in mid-May or in mid-June? Now again, the program will allow you to sort of explore that in a shorter term, but you'll still want to see it because this is obviously not your horizon. You want to see where it sets along your horizon over an extended period of time. In fact, you could do this for an entire year. Now, that doesn't mean you need to watch it every night, and as you know, our weather isn't going to permit that you watch it every night. So instead, you could perhaps look where the sun sets maybe once a week, maybe even once every 2 weeks, and then you can notice changes. Of course, if you give yourself a couple of weeks, eventually within that time period, you should have some clear evenings. So you'll want to write down now 3 things: where the sun sets, or draw where the sun sets along the horizon. You want to make note of what time the sun is setting, and we'll include in that idea of time the date where the sun is setting in any particular location. So in order to advance this idea, let's indeed advance forward. Now, there are a couple of ways that this particular program does that. You can do it on a keyboard. You can also use some of the buttons that are on the side. If you move your cursor over toward the left or toward the bottom, you can see various buttons and so forth show up. In this particular case, there is a date time window. So if we open that up, you can see appearing on the screen the date. It's 2020. The month is the 4th month, or April. It's the 14th of April in this particular image. So you could change the time by changing the month. And up would be increasing, down would be decreasing. So if you want to go forward 1 month, you can click on the up arrow. And we're now looking at the sun in May. Now, we haven't changed the time. Time's advancing just kind of in a normal fashion. It's now about 8 minutes after 7. And if I close this window, let's see if we can find the sun. Well, it's kind of hidden behind that tree. We can change that. We can actually change our view by removing the horizon. Now, you can do that again with a lot of the different things on the buttons, but it's quite easy to change this by simply using the letter G. G stands for ground in this case. And if we eliminate the ground, that eliminates the horizon, which includes that tree, which is in the way of the sun. So there's the sun. Now, of course, now you don't know where the horizon is. So we're going to add in the horizon. Very simple, horizon H. And you'll now see a bright line appearing right along the horizon. But if we move back in time, if we go back to April, we'll use the time function once again. And we'll leave this horizon just as a line there. And if we go back to April, you can see that change. So again, and keep an idea, there's the sun. That's where it is on April 14th. Now on May 14th, two things have changed. The sun has moved more to the right, and it's also positioned higher. As of course, we're now a little bit later in the year. The days are a little bit longer in May than they are in April. So the sun is higher above the horizon. In other words, it's going to take longer for it to set. We can go forward one more month. We can go to June. Now, of course, the sun is behind our window. We can kind of move that out of the way. Obviously, the sun is higher in the sky, and it's even more to the right, or shifting toward the northwest. So if we think about where the sun is setting along the horizon as we go forward in time from April to May to June, the sun doesn't set along the same place along the horizon. In fact, we'll speed up time here. Let's close our time window. And as we speed up time, and you can watch the sun sets considerably farther to the north and west. We're very close to the first day of summer, June 21st, and so that's about as far as the sun is going to set in the north. And again, you can actually observe this from your location. It may set at a different time because you may not have a level horizon toward the northwest, but it is something that you can mark. You can measure the location that the sun is setting or draw it. You can also mark the time when it's setting, and you can mark the date at which it sets. So another process that you'll want to undertake, and again, this is a long-term project, but as you draw out the horizon and you mark where the sun sets at different dates, you'll also want to notice, is the sun just going to simply keep setting more and more to the right? You can make an observation about that, but you may want to mark where the sun sets, and if it changes, if it stops going toward the north, or if it changes and starts going in the other direction toward the left instead of the right. So these are all observations you can make during the daytime using the sun as a way of demonstrating the movement and rhythms in the heavens. So this is one of the key things. If we're talking about motion in the sky, we're seeing the sun change. It moves across the sky. Now, this idea of change in the sky is something that's not unique to the sky. All kinds of things in nature change. You and I change. Animals and birds change. The weather changes. By watching and observing these changes, in some ways, it gives us an opportunity to predict what change is coming next. That's a pretty obvious thing in the weather. We often try to project what's going to happen later in the day, the next day, sometimes even a few to several days ahead of time. The ability to do that comes from observing the weather, seeing how it changes, and understanding why the weather changes. The idea of understanding those changes is a key thing to predicting changes in the future. And so that's the idea with making these observations along the horizon, watching where the sun appears, and then making a prediction based on your observations. The better your observations, the better the predictions. And this is a common practice throughout all of science. People observe, for example, in biology. They may notice particular changes in larger creatures, ourselves, or perhaps different animals, how they change over time, and make predictions about that. But it may take place at the cellular level, tiny little changes taking place in cells and how that changes. These allow predictions, and in the case of biology, sometimes medical treatments change because of what we can observe. And this is a critical thing in the current pandemic that's been going on. Understanding this particular virus allows us to be able to see what's going on, predict its changes, and perhaps affect how we can protect ourselves from that particular virus. So this is all a part of science. Getting back to our astronomy and observing the motions in the skies, we've been watching the sun mostly at sunset. But let's take a different look at the sun now. So we're going to change our view. We're going to zoom out just a little bit more. And we're going to change our time just a moment. So hang on, we're going to change our screen here. Our next program is using something called Celestia. Now this is a program that allows you to see, well, a different view. Instead of looking at the sky the way you see it, we're actually going to go out into space and take a view that way. So let me just share that particular image with you. We'll take a look at that, and hopefully we'll be able to get that to engage. We'll be able to change the motion. So first view that we have is simply, there's the Earth. And you can maybe see there's a slight motion to it. We can increase that motion. Again, this is another program that you can download for free. And there are lots of things you can do with it. I think it's a little trickier to use than Stellarium, but it does give us the advantage of seeing the Earth in its actual motion. So let's do that now. In fact, let's perhaps increase the motion here. And you can do that. There are a couple of ways of doing that. You can use the keyboard, but you can also use the menu up on the top. So if we do that and we start increasing our speed here, you can see the Earth is now spinning or rotating. And that, of course, you know, is the reason that you actually see the sun move across the sky. We have the Earth in motion. It rotates once every 24 hours. Now, this motion is one of the keys to the motions that you see in the sky. So we watch the sun. It comes up in the morning, goes down in the evening, each and every day. Obviously, you don't see it every day because of the cloud cover, but you know that's the daylight and darkness. But you also know this is the reason what you're watching right now. You can see the Earth is gradually spinning around. So we know that's part of the 24-hour motion. But we also saw the motion that took place during a period of months when we were watching the Earth and seeing how the sun set at different times during the different months. So what's going on there? Obviously, that's not just the spinning of the Earth. The Earth would have to shift around, and that doesn't really happen. So let's see if we can find out. We can figure out what's going on. So this is a motion of the course of the Earth, but there is another motion the Earth makes. I think you can probably guess what that is, but we're going to help you out with that. We're going to navigate or change our view. We're going to select the sun, and we're now going to go to the sun. Now, I guess it's going to ask me what object I want to go to, so we'll say go to the sun, and off we go. And there's the sun. Now, we don't want to look maybe quite that close. We're just going to back out a little bit. And in fact, one of the things is, of course, the Earth is going around the sun. So how can we see that? How can we demonstrate that? Well, this program allows you to see the orbits of the planets as they take place. So we're going to introduce that now. We're going to simply use the keyboard and use the letter O, and suddenly all these blue lines appear. Well, if we get a better perspective here, we're going to move away from the sun a little bit and also change our view slightly so that we get a little bit of an angle here, so that now as we zoom out, you can see the orbits of the major planets. No surprising view here now. I think you've probably seen this in many textbooks and so forth. And we can change our view in terms of the angle that we're looking at. So in other words, as we look more straight down, you can see the orbits there. And again, we can kind of zoom out so you can see them a little better. Or we can change our angle again so that we're taking more of a side view. And there you can see an edge-on view of the orbits of all of the planets. Now, one thing you probably noticed, they're all orbiting at about the same level. Some slight variations, but all pretty close. That'll be something that we'll discuss in some further episodes. But for today, we really want to concentrate on the motion of the Earth. So let's change our view again. We'll get a little bit of an angle, and we'll zoom in a little bit closer so we can see the orbits of the inner planets. And so if you look, you can, of course, see the closest planet, Mercury, followed by the next planet out, Venus. Here's the Earth right here. And finally, we have Mars. So the other motion that the Earth makes is the Earth, of course, is going around the sun. And we can set that motion. We can increase that motion. You can see the sun stays centered and all the planets are going around it. Of course, they don't go all at the same speed. Again, this is something that we'll discuss in a further edition of this, where we'll talk about the motions of the planets as we view them in the sky. But for right now, we can see the Earth traveling around the sun. And of course, that means that we're looking at it from a different direction all through that period of time. That doesn't necessarily suggest that you would see a different view of the sun in our skies. It could certainly seem to stay the same. There is one other key thing that isn't terribly obvious in this particular view. So let's let this just kind of pause. We'll slow that motion down. And we have one more image to consider. Now, we've been talking about the Earth moving, one on its axis spinning around. That's our daily motion. We just saw the sun going, or the Earth going around the sun. That, of course, takes place during the course of the year. But one other thing that's of important consideration has to do with the angle that the Earth is spinning. So to do that, we're going to offer just one more picture here. Let's see if we can find it. It's located on here somewhere. Hang on. I've got a lot of pictures up here. There it is. So let's take a look at this particular image. And we'll get a fuller image here. We're going to do a slideshow view. And so there you have the sun. It's our nearest star. And in this particular case, if we think about its motion, there's the motion that we've talked about earlier, but this is based on where we are. You can see a little person standing in the middle, and you can see now some dates along the bottom, December 21st, March 21st and September 21st together, and then June 21st on the right. What you notice is the path of the sun changes depending on the time of year. Again, this is the challenge that I offered earlier for you to draw the horizon and watch where the sun sets along the horizon. You can obviously do the same thing in the mornings, but chances are you'll see more sunsets than sunrises. Now, this change that we can observe in the sky has a reason. It has to do with the Earth's tilted axis. We are not straight up and down. If you look at the picture, you can see at the image of the sun, and then just below it, the Earth, you can see the angle. It's actually written there, 23.5 degrees. That is the angle that we're tilted. Now, why is that important? Well, as you notice the Earth and its motion, notice that as the Earth goes around, the North Pole's angle, and that's the North-South Pole, the Earth's axis, doesn't change throughout the year. It remains at that same angle. What does change is where we are in relation to the sun. So as it moves to the right, or in this case, toward the winter position, you can see the North Pole is angled away from the sun. The North Pole didn't change its angle. It's simply a matter of where we are relative to the sun. But it changes where we see the sun in the sky. Think of it this way. If we are angled away from the sun in the northern hemisphere, that's going to shift the sun toward where it's higher in the sky, the southern hemisphere. So it changes where we see the sun in the sky. It shifts it toward the south during the winter. As the Earth continues around, we get to the next equinox. Of course, after winter, that's going to be the spring equinox, pretty close to where we are right now. And then eventually to summer, which is on the left-hand side. Now you can see the North Pole is angled toward the sun. We've shifted toward the sun. The sun is closer to the North Pole. It's closer to north in our skies. That shifts it from down low in the sky toward the south, up higher in the sky. Although, locally, it never appears directly above us. The Earth's curved surface and our position means that we never see the sun directly overhead. in our skies. So that's just a look at where you can see the sun in the sky. And in fact, we'll do one more thing before we finish up here, just so that we can get a sense of what I just described. But in this case, we're going to take a look at how you would see it in the skies. So we're going to use that program called Stellarium again. Now, when we last left it, the sun was setting in June. That's a fine place actually to start. But we're going to change our view. We're going to add the horizon in. And we're also going to move our view toward the south. So here we are looking in the south, and of course it's sunset. So let's change that a little bit. Let's actually go backwards in time, and that's actually easy to do. You can use the time function over here on the left, or you can actually use a couple of different buttons. One of them, the plus and minus keys, will actually take you forward and backward day by day. But we only don't want to do this hour by hour, so we're going to go backwards by holding down the control key, hitting the minus key, and you can see it's getting much brighter. The sun is located there in the sky. The date is June 14th, which is very close to the summer solstice. Let's bring the sun just a little bit higher by simply changing the day. Instead of holding the control key down, just simply push the plus key. And we go forward in time. You can see the date on the bottom. That's going to be increasing, going up a little bit higher. And so there we are on the 21st. So that's the sun at its highest point in the sky. Now, how do we keep track of that? Well, there are two lines that I think that are very helpful. One, we're going to introduce a line here, and we're going to come over to our sky viewing options. There are lots of different markings that we can add to the view here. So in this case, we're going to add something called the meridian. It simply is going to go from exactly north to exactly south. And you can see that line now appearing here, and there's the sun. But we're going to add one more kind of piece of information that will help us. We're going to add a grid. Now, all kinds of boxes have suddenly appeared. We can make this fairly simple. The lines that are parallel, the same line as the horizon going up and up and up, these are in tens of degrees. So this lower one, just above the southern horizon, is 10 degrees above the horizon, 20, 30, 40, 50, 60, almost to 70. That's where the sun is, almost at 70 degrees. That's the highest that the sun gets in the sky. Now, if I shift our view just slightly, that's the very top of the sky. So the sun never gets to the top of the sky. This is its highest position. At the same time, we'll just kind of shift our view back down. We can change our view by the date, and we're going to do that now. We're going to keep this box over here just so that we can see. Here it is, June. So we're going to go forward in time, and you can see here's July and August, September, October, November, December. Well, two things have changed. Suddenly the sun has shifted well to the left, but you might have to remember we have changed to standard time instead of daylight saving time. So if we go back over to the hour box over here where it says Julian date, we're actually going to change the hours here, and we're going to change that back 1 hour. And there the sun is back closer to the meridian line. But notice where it is now, 10, 20, maybe a little bit more than 20 degrees above the horizon. So this is at noontime, or very close to it. Quite a change from the winter to the summer. So that's another thing that you can observe in the sky. So there are plenty of observations that you can make. This is a good place to start. As we continue on this series, we'll be talking about the motions of the stars. We're going to talk about the motions of the planets, and we're also going to watch the moon. The moon's one of the more complicated objects in the sky, and we'll continue our discussion on the movements and rhythms in the heavens next time. Thank you.